Hey guys, Mr. Backerberg here. In this video, we're going to look at distance from a constant velocity. We've all seen the formula d equals rt before. Distance equals rate times time. So if we're dealing with an object and we know its rate, its speed, and we know the time period, how long it's traveling at that speed, we can use this formula to calculate the distance traveled. So for example, if we were dealing with a car and we knew that it was traveling at a constant rate of 48 miles per hour for 2 hours and 30 minutes, we can figure out how far that car traveled. So if we take distance equals the rate times the time, then we're going to have distance equals the rate, which is that 48 miles per hour, times the time, and I'm going to call it 2.5 hours. So if we take and multiply that 48 by that 2.5, then we're going to get 120 miles as our distance traveled. Now this problem is somewhat similar to what we saw happening back in 11.1. But in 11.1, we called our distance traveled, we called that delta S, and we called our time, we called that delta t. Now I'm going to leave the rate as r in here. So what I could say is that delta S is equal to that 48 mile per hour rate times delta t. And then what I could do is divide that delta t over to the left-hand side to get delta S over delta t equals that 48 miles per hour. And back in 11.1, this delta S over delta t, we called that our average rate of change. So this car doesn't necessarily even have to be traveling at a constant rate of 48 miles per hour. It could only be averaging 48 miles per hour, and we could get the same result. Maybe it sped up, maybe it slowed down, maybe it stopped. But as long as it's traveling an average rate of 48 miles per hour for that 2.5 hours, it's still going to cover 120 miles. So whether we're given a constant rate or an average rate, those are going to end up with the same results. But with that average rate of change, our car could have slowed down, it could have sped up, and it could have even stopped, but we still cover that same amount of distance. But if we're talking about the instantaneous velocity at any given time, like we saw back in 11.1, typical algebraic techniques aren't quite enough to help us figure out what the instantaneous velocity of our car is at any given time along its travel. That's going to be it for this video. Thanks for watching.